Picture this. You're standing at a grill on a sunny afternoon. You've got a beautiful cut of meat searing over the coals, perfectly cooked, smelling incredible. It's a ritual you've probably taken part in dozens of times. But look closer at that plate, and a weirdly simple question pops up. Why is that meat almost certainly from a cow, a pig, or a chicken? Why is it never from a wolf, a lion, or a tiger? The easy answer is to shrug it off as a cultural quirk, a taboo. Or maybe you figure that predators are simply too dangerous to hunt, so early humans ignored them entirely. The historical record proves otherwise. Indigenous hunters have harvested wolf. People have cooked bear, alligator, shark. The meat exists, and humans are entirely capable of hunting it. Yet basically zero societies on Earth built their baseline diet around consuming apex carnivores. Our culinary choices are the direct output of a rigorous biological calculation that our ancestors ran for thousands of generations before they had the language to describe it. The first barrier keeping carnivores off our menu comes down to sheer thermodynamics, governed by a strict law of nature known as the 10% rule. This diagram breaks down how energy transfers up the food chain. Let's say a patch of grass holds 100 units of energy from the sun. When a deer eats that grass, it burns 90% of that energy to move, breathe, and generate body heat. The retained energy drops to exactly 10 units. When a lion comes along and eats that deer, the exact same math applies. The lion retains only 10% of the deer's energy. By the time you reach an apex predator at the top of this pyramid, you are feeding on the leftovers of leftovers. Imagine you are a hungry prehistoric hunter. You have a choice. Risk your life battling a lion for 15 pounds of severely depleted, low-energy meat, or hunt the deer. The deer offers a massive return on your calories for a fraction of the danger. From a purely mathematical standpoint, targeting a predator guarantees a terrible caloric trade for a starving human. A bad caloric return only scratches the surface. The second barrier is an invisible, compounding threat hidden inside every living apex predator today: biomagnification. This visual web tracks exactly how pollutants compound in an ecosystem. Toxins, like heavy metals, enter at the bottom in tiny, manageable doses. When a small fish eats thousands of these contaminated organisms, the toxin builds up. A medium fish eats thousands of those small fish, concentrating the dose. Finally, a large predator fish consumes them, and its toxic load glows intensely red, representing an exponential concentration of poison. In 1966, a scientist named Charles Worster studied a mysterious die-off of eagles along the Great Lakes to see how this compounding effect worked in the wild. The eagles weren't interacting with environmental poisons directly. They were eating local fish, which had absorbed massive amounts of the pesticide DDT from the lower levels of the food chain. By the time the eagles consumed them, the chemical load was so concentrated it caused their eggs to crack before they could ever hatch. Land predators face the exact same physical reality. Over a lifetime of hunting, accumulate heavy metals and synthetic chemicals that their body simply cannot break down, storing them permanently in their fat tissue. Consuming an apex predator means consuming the compressed, toxic archive of the entire ecosystem that sat beneath it. Even if you could filter out the heavy metals, carnivores carry one final physical threat. A lifetime of eating raw flesh brings an immense amount of biological baggage. Their digestive systems and muscles host complex parasites that have evolved alongside them for millions of years. The most notorious is Trichinella, a microscopic organism that thrives deep inside carnivore muscle tissue, causing brutal pain and severe fever when it hatches inside a human host. Bear meat sits on record as one of the most historically documented sources of Trichinella. Every indigenous culture that harvested bear knew you had to cook it flawlessly, or the physical consequences were catastrophic. Our immune systems were never built to handle the aggressive, stockpiled parasites found inside an animal that spends decades devouring other animals. This leaves us with a final mystery. How did our ancient ancestors know to steer clear of these thermodynamic deficits, toxic archives, and microscopic parasites without chemistry textbooks or microscopes? They didn't. Instead, millions of years of ruthless evolutionary pressure took that trial and error data and programmed it directly into our physical instincts. Dr. Paul Rosen, a psychologist at the University of Pennsylvania, spent decades studying human food psychology. he found that humans consistently categorize meat from carnivores as deeply pre-rationally aversive. We are repulsed by it before our conscious brains even have time to evaluate it. There are careful exceptions, of course. We occasionally eat mid-level predators like tuna, squid, or alligator because they sit just low enough on the food chain for their toxic load to stay manageable. True apex predators, however, cross a hard threshold of survivability. The disgust you feel at the thought of eating a wolf steak serves as a downloaded survival mechanism, inherited from the ancestors who found the idea unappetizing and lived long enough to pass that feeling down to you. The everyday plate of beef, pork, or chicken represents the physical, living result of millions of years of selection pressure. That visceral flash of hesitation you get when imagining predator meat is your ancestral memory speaking to you. It is the exact same instinct that kept them alive, working perfectly to protect you today.